First things first, what are electrolytes? So when we hear the term electrolytes, we have to understand that electrolytes are substances that are dissolved into water. Now, electrolytes, you've probably heard of Gatorade. That's where people typically hear this from. Gatorade replenishes your electrolytes, and that's true. What electrolytes are ions that are dissolved into solution, specifically, okay? So you can see here that this really is what an electrolyte is. So when you, as you're taking notes, make sure you know these basic definitions, okay? So electrolytes are ions that are dissolved into solution. And so when we talk about solutions, solutions are composed of two different things, okay? And the first thing is the solute. The second thing is the solvent. All right. Solute is what's being dissolved, and then the solvent does the dissolving. All right. Now, if we put NaCl into water, what happens to the NaCl? It dissolves. Now, it also does, on top of it dissolving, dissociates. And so in the solution, you form sodium ions and chloride ions. These sodium and the chloride ion are called electrolytes. All right. So anything that's considered an ion is considered an electrolyte. All right. Not everything is going to form electrolytes, but some things will form. Okay. And so we get to these terms that are called strong electrolytes, weak electrolytes, non-electrolytes. And so that's where we're getting to, is we want to try to understand and establish what the boundaries are to doing, whether you're dealing with a strong electrolyte, weak electrolyte, or a non-electrolyte. Okay. So but the first thing is you have to understand what an electrolyte is. It's something that's dissolved in solution, an ion specifically. Now, when we talk about non-electrolytes, so non-electrolytes may dissolve in water, but it does not dissociate into ions when it does so. So non-electrolytes dissolve, but they do not break down into respective ions. Okay, so NaCl is considered an electrolyte. What might be a good example for a non-electrolyte? All right, so go to your restaurant, you get a glass of sweet tea, you need to sweeten it up a little bit, so you add some sweet and low in. All right, sweet and low goes in the solution, dissolves, makes it sweeter. That's a good example of a non-electrolyte because the sweet and low dissolves, but it does not dissociate. Everybody understand that? All right, so let's get into discussing electrolytes. And the first thing we get to is discussing strong electrolytes and weak electrolytes. All right, so soluble ionic compounds tend to be electrolytes. The key word here is soluble because this references the solubility rules. Now, one thing that you are going to be using is your things I should know handout. All right, so I'm gonna write this up here. You need to have this handy. All right, things I should know. This is on Moodle at the top page. So the things I should know handout has your polyatomic ions. It has your solubility rules. It has your electrolytes. It has the types of chemical reactions. There's a lot of information that you find on that handout. So that's a good resource to have handy while we're doing this information. Okay. So, jump too far. All right. So when we talk about electrolytes, so strong electrolytes. So what is a strong electrolyte? It's a compound that dissociates completely. Okay. So what this is it dissociates completely in solution. All right, good example of sodium chloride. Sodium chloride dissociates into sodium ions plus chloride ions. So it breaks down completely. Another example would be potassium sulfate. Okay, potassium sulfate breaks down to 2 potassiums and 1 sulfate. All right, so these are a couple examples of strong electrolytes. Now, if you look on the things I should know handout, all right, you will see strong acids. All right, there's a list of strong acids. There's 8 of them. Okay, what you need to do is you need to look at those 8 strong acids and understand. Now I'm gonna pick out 3 randomly. Okay, so HCl will be one, HNO3 will be another, and then HClO4. All right. Now those 3 are a part of that strong acid list. That means that these are also considered to be strong electrolytes, okay? And so that goes to the fact that they're going to dissociate completely. Now, so when we talk about strong electrolytes, we have to understand that, hey, they all dissociate completely. Now, when we get to weak electrolytes, that's where it gets a little bit tougher because you have to try to understand what exactly does weak mean, okay? Weak versus strong. All right, now, so let's talk about weak electrolytes. Okay, so I'm gonna erase what I've got down here. All right, so you have weak electrolyte. So weak electrolytes do not dissociate completely. We call this a partial dissociation. Now, the parts that do dissociate will break down into their respective ions. So there are 2 that you need to remember, okay? And this is on the things I should know handout, all right? Now these are 2 acids, but there's a lot of different compounds that are weak electrolytes, but there's 2 of them that I ask you to remember. Those 2 are on your things I should know handout. The first one is hydrofluoric acid, and the second one is acetic acid. Both of these are weak electrolytes. Both of these will not dissociate completely. And so when you look at HF, the way it's written is with this arrow. All right. So if you notice that it has this double arrow, that right there tells you that you're dealing with a weak electrolyte. Same thing for the acetic acid. All right. So it also has this double arrow. That double arrow tells us that this is a weak electrolyte. Move on then. Okay. So non-electrolytes are everything else. Okay. So long story short, sugars are great examples. Okay. Sugars are good examples, great examples of non-electrolyte. One specifically, C6H12O6. I put a star beside it and I boxed it in because that's the one I want you to remember. All right. Other ones can be CH3OH. This is methanol. Another one is CH3CH2OH. Remember organic nomenclature. This is methanol. And this is ethanol. All right. So these are all examples. In fact, this compound that you see here, this is your methanol. So that's what they're showing you there in that example. And all these other molecules that are surrounding, those are water molecules. All right, so that's enough for electrolytes today. I don't want to spend a ton of time on electrolytes. So strong electrolytes will make a light bulb go off very brightly. Weak electrolytes will make this light bulb very dim because it don't conduct electricity very well. Strong electrolytes conduct electricity very well. That's why the light bulb is very bright, even though in this picture you only see one picture of it. If we were in class, I could show you the demo that where you can really see the difference. So strong versus weak, and then you get the non-electrolyte, which it will not do any conduction of electricity because there's no ions present. If you were to be electrocuted, I would suggest the person to dip the sponge into a strong electrolytic solution. That way it conducts electricity very effectively. If you watch The Green Mile, they put a dry sponge on top of the guy's head, which basically didn't conduct any electricity, so it fried him. It was very, very gruesome. If you've watched that movie, you know what I'm talking about. If you haven't watched The Green Mile, it's a great movie, but that's probably the worst part about that movie, and the fact that I can't tell you anything else. Okay, I'm gonna be quiet. Moving on. All right, let's talk about solubility rules. Okay, this is really what I want to get to today. What we're going to do on Wednesday is we're going to talk about double replacement reactions and single replacement. I'm going to try to get a bunch of it knocked out. If not, it will be posted in separate lecture videos. All right. So for today, we're just going to focus on this solubility rules. Now, you need your things I should know handout. You'll find those solubility rules there. All right, you can use this set here, or you can use the ones that you find on that handout. All right, you're going to find more on the handout that you're going to find here, just FYI. So the compounds, there's two different categories, okay? You have the first category, which is soluble ionic compounds, and then you have the second category, which is insoluble ionic compounds, all right? So if we look at NaCl, because that's the one we're so comfortable with, all right? If you put sodium chloride in the water, it dissolves. Easy enough, right? Well, if we look at the solubility rules, we'll understand why, all right? So we have to look at the anion, all right, the negatively charged part. So it's the chloride. So we look at the chloride here. Now, chloride is found in group 1, meaning that all chlorides are soluble, meaning that all chlorides are going to dissolve into water. Now, there's always an exception to the rule. If you look at this part, it says important exceptions: compounds of silver, lead, and mercury. So when I go back up and I look and say, hey, is this silver, lead, or mercury? The answer is no. So that means that sodium chloride is soluble. Now, let's take the opposite. Let's say we take AgCl. Now, we still go back and find the Cl. Okay, Cl's in the soluble category. We established that a minute ago. Compounds of silver. Okay, stop for a second. This is silver. This is an exception. That makes AgCl insoluble because it's an exception to the rule in the first group. So anytime you have an exception, it's going to make it insoluble in group 1. All right. So
Mr. Shelton,
Yep.
could you explain that in a different way? Because I don't necessarily understand.
I I could, but I don't really know how to explain it a different way. It's just that easy. What part don't you understand? Let me ask.
Because you said that when you have NaCl, that makes it soluble. But when you have AgCl, it makes it insoluble. How does the Ag make the Cl? How does Ag, when you combine Ag with the Cl, how does that make it insoluble?
All right. Do you see that the AG is in the exceptions group?
Yes.
If it's an exception, it makes it insoluble.
Okay.
All right, and that's in group one. All right, so be careful. So when you're looking at this box, we're only focused on this box right now. All right. So if I put, let's say I had lead iodide. All right. Now, what ion are you going to look at? Are you going to look at the lead, or are you going to look at the iodine to begin with? Iodine. Good. So we look at the iodine, and we find iodine in group one. That means that iodine is soluble. Now we go look at the exceptions. Silver, mercury, and lead +2. All right. Now it's got to be lead with a +2 charge. So I'm going to look at lead here. All right. We can look at the periodic table, and from the periodic table, we see the charge of iodine being -1. So this is -2 overall. All right. Now, this compound is equal to 0. It's a neutral compound. That's why it's 0. So 2 minus 2 equals 0. I look at the lead, I see that there's only one lead. That means that lead is +2. Now, if this is something you're having problems with, you need to go back and look at the nomenclature rules. Okay, this comes back from the beginning semester. All right. So I look at the fact that it's lead +2. It matches up with this. That makes this compound insoluble. So you got to be really careful when you're working with these types of compounds. Okay. I say that because sometimes you're going to get a compound that has, you're going to have the lead. Okay. I'll give you an example here. So PbSO4 2. All right. Now, if I look at this compound, I'm gonna work it out down here on the bottom of the page here. So if I look at this compound, what I want to figure out is what's the charge on my lead. Now, sulfate is a polyatomic ion. It has a charge of -2. There's two of them. And so 2 times -2 gives me -4. Now, I know this is equal to 0 because it's neutral. There's no charge given. So 4 minus 4 equals 0. There's only one lead. That means that lead is +4. Now I come back up to sulfate and I see sulfate is in the last row. The exceptions are strontium, barium, mercury, and lead with a +2. I come back here and I see, okay, my charge of this lead is +4. That's not +2. That means that this compound is soluble. So you got to be really careful and looking at the charges of those transition metals, which lead is. All right. Okay. So group two, it's this deals with insoluble compounds. Okay. So this is the opposite from what we just saw. So everything in group one is soluble. everything in group 2 is insoluble. Now we're going to be focused on this group. All right, so I'm going to erase what I got up here, and then we'll do an example too. So our teeth are composed of calcium and carbonate. So what I'm going to do is I'm going to find carbonate. So I find it, it's right here. Now I want to do is look at and see if calcium is an exception. So all carbonates are insoluble because it's in the insoluble category, unless you're part of the exceptions. Now, calcium is in group 2A, which is the alkaline earth metals. Now, as I look at the exceptions, compounds of NH4 plus 1 and the alkali metal cations. Now, I said alkaline earth, so that means that this is going to be not an exception. Okay, so if this is not an exception, that means that this compound is insoluble. Now, here's where this comes to truth. How many of you drink water? We all drink water. How many of you dissolve your teeth when you drink your water? No one does. You know why? Because your teeth are composed of calcium carbonate, and calcium carbonate is insoluble in water. It will never dissolve into water. So your teeth are fine to drink water. And you are like, wow, that's just perfect. It makes sense now. And I said, great, let's move on. So now we have NH4 hydroxide. So ammonium hydroxide. So I'm going to look up the OH. All right, so OH is found right here. And I'll have to figure out, is ammonium one of the exceptions? So compounds of the alkali metal cations and ammonium. Okay, here it is. So ammonium is an exception. And being an exception in group 2 makes this compound soluble. Now, a word of advice is that when you go to the store, you buy a bottle of ammonia. And what ammonia is just this compound. It's ammonium hydroxide. If you look at the ingredients on the back of an ammonia bottle, you'll find that the ingredient is not ammonia. The ingredients are ammonium hydroxide because that's what's dissolved in the solution. Just a couple of things there, right? It's just whatever. All right, let's do another one. Let's do zinc sulfide. Anybody want to take a stab at this one and tell me if it's soluble or insoluble?
It would be insoluble, wouldn't it?
Yep. Yes, that's right. Insoluble. Thank you very much. All right, and so if we look at sulfur, it's insoluble. And we've got to figure out, is zinc an exception? So you have NH4 plus, alkali metal cations, calcium, strontium, and barium. Zinc is not an exception, so zinc sulfide would be insoluble. Everybody understand that? So I need you guys to take a picture of this table right now. All right, take a picture of this table. All right, got your picture taken? So what we're going to do now is this exercise. I want you guys to do A through K. Sydney, tell me what you get for A. I'm gonna write it on paper here. What you get for A?
For A, I got soluble.
Okay, all right, good. So I'm just gonna write S for soluble and N for insoluble. Okay, what about B?
B is insoluble. We already did that one, so.
Yep, right.
C is soluble.
Okay, what about D?
D is insoluble.
All right. Now before we go on, so iron 3 oxide is rust. Rust forms on your car. When it rains, does rust dissolve off your car?
No, because it's a chemical reaction.
Exactly.
It's irreversible.
Exactly. That's why it's insoluble. Thanks. Good one. Okay, what about E? We did that one already, didn't we?
Yeah, I think we did, and that one was insoluble, I believe.
Awesome. All right, what about F?
And then F is soluble.
Yep.
And G is insoluble.
Okay.
And that's as far as I got.
That's as far as you got. Did anybody get H? Devin, did you get H?
Not just yet. I can look at it though.
All right, let's do it. Okay, so bromine is found in group 1 or group 2? Where's bromine found at? Solubility rules.
Group 1.
Okay, so that's insoluble. Now, is iron one of the exceptions? Yes or no?
No.
All right, that means that this compound is soluble or insoluble?
Soluble.
Right, good. All right, let's see here. Thanks, Devin. Samuel, are you there? Do you want to try to help out with the next one? Letter I.
Sorry, give me just a couple minutes. I got distracted with something else.
All right.
I'll be right.
Okay. All right. Where is sulfate found at anybody? Is sulfate in group 1 or is it in group 2?
It's generally soluble according to my things I should know handout.
Okay, yeah. So what would you put on that? S or IN?
It would be S.
All right, good. That's perfect. All right, now letter J is tricky. Okay, letter J, I'm just going to tell you that letter J is soluble, but it also is insoluble. It's a weirdo. All right, so if I go back and look at hydroxide here, okay, so if we look at hydroxide, which is the bottom here, hydroxide is insoluble except with calcium ions. All right, so that means that this compound is soluble, but you also will note that if you take Chem 2 next semester, you're gonna see this compound because we're gonna work with it. You'll see that it forms a white precipitate on the bottom of the test tube, and that means that it's also insoluble. So, but for the part that does dissolve, it dissolves completely and dissociates completely. All right, so that's why it's soluble. All right, so just a FYI on that one. Now letter K.
Oh, sorry.
I know what it says on the things I should know handout. Yeah, tell me what you're going to say.
I was going to say, would this be one of those sparingly soluble type situations?
Exactly right. That's exactly what I would hope you to see, because that's what you did in lab. Yeah, good. All right, so what was it? Carbonate. So carbonate is found in the insoluble category and is Hg one of the exceptions? No. So this next one is insoluble.